Good afternoon, everyone. I would like to tell about the information system for drone monitoring of trees condition. In this presentation, the goal is to create a system using HML methodology, so here I would like to represent activity, sequence, and state diagrams. Moreover, I will also describe implementation methods and tools, and explain some function algorithms. In the end, I will represent the first version of program realization. So, I would like to start with the activity diagram. This diagram describes the user behavior with the program. First of all, the user downloads scan results. If the images are poor or inappropriate, it returns to start. Else, the user can choose to create characteristics and download the necessary files. If they are inappropriate, the program will ask to download them again. In the next step, user will choose data analysis and after that, to form recommendations. In the end, the user will get a report of the analysis. Now, I would like to represent the sequence diagram, which shows the interaction of certain instances of actors and classes. There are four class objects such as user, scan result images, characteristics, analysis, and recommendations. Let's start with the messages between these objects. Firstly, the user downloads scan result to the scan result images and then downloads object passport, previous researches, and statistical observations to the analysis. After that, the object of scan result images process the images and send a list of obtained data from images to the characteristics. The characteristics make the taxation and force pathological characteristics and set them to analysis. The analysis compares object passport and previous studies with characteristics, analyze the tree's condition, and display a list of previous studies and the result of the analysis. In the end, the recommendations choose prevention options and options to improve the tree's condition and send them to the user. The last diagram is a state diagram, which visualizes the state of program during each step of using. So, when the user starts using the program, it is waiting for data to load. If the images are downloaded and have good quality, the program starts image processing and then creates characteristics. If the necessary files are downloaded and characteristics are created, the program makes the comparison of the obtained data. If the data are compared, the program starts to analyze them. After that, it finds prevention options and options to improve the tree's condition. In the end, the program makes a report and returns to start. Now, I would like to represent the implementation methods. Among them are creating a program for computer user. Files of taxation and forest pathological characteristics must be created in CSV files. Creating a database by pandas. Creating a report and saving it as PDF file. Classification trees by their diseases. For this program, I decided to use such machine learning algorithms as tree classification and Cummings clustering. So, tree classification algorithm use a decision tree to go from observation about an item to conclusions about the item's target value. In these tree structures, leaves represent class labels and branches represent conjunctions of features that lead to those class labels. There is also represented the block diagram of using this algorithm in the orange tree environment. I would like to show how it works in this environment. I choose the target value of needle falling. The widget tree viewer shows that there are 10 trees which have this sign. Also, I use the data table to show these trees' identifications. Another algorithm is Cummings. It is a method of vector quantization originally from sign processing that aims to partition an observation into clusters, in which each observation belongs to the cluster with the nearest mean. This algorithm outputs a new data set in which the cluster index is used as a class attribute. There is also represented the block diagram of the using this algorithm in the orange tree environment. Now I will explain how it works in this environment. I choose the target value of having a tumor. The widget scatter plot shows that there are 5 values which have this sign. Also, I used the data table to show this tree's identification. For creating the program, I use such implementation tools. Windows 10, Programming Language Python version 3.6, PyCharm Environment Community Edition, Qt Designer version 5.13. Also, I use such Python libraries: PyQt5, Pandas, Statistics, and CSV. Now I would like to represent some function algorithms. Function db from CSV creates a pandas database from CSV file. Function average age counts the average tree's age from previous and current researches. This algorithm is also used to count the average tree's height and diameter. And the last one is function tree kind, which finds the most common tree kind in the researched territory. This algorithm is also used to find bonneted forest type, soil, and relief. The RIS represented the program realization. On the figure 1, it is the initial program window. When the user downloads the previous and current receipts and clicks on the button Analyze, he or she gets the average value from previous and current receipts and its evaluation of the right part of the window on the figure 2. Also, the user gets the general information about the researched area, which is located on the left part of the window on the figure 2. Moreover, the user can also see the information about the program shown on the figure 3 and the instruction of using the program shown on the figure 4. To sum up, I illustrated the UML diagrams such as activity segments and state diagrams, which shows how the system works. Also described some implementation methods and tools, and in addition represented the program realization. This program is just first version. It will be gradually improved and more developed. Thank you for your attention.